This is the first video on Year 2 integration, and it's just looking at some of the standard integrals you need to know. The good thing about integration is if you're ever not sure what the integral of something is, you can kind of work out what would differentiate to give me that. Okay, so for example, if we take the second one here, the integral of e to the x, you should know from differentiation that when you differentiate e to the x, you get e to the x. That's the point of the irrational number e, is that it differentiates to give the same thing. So when you integrate e to the x, you also get e to the x. Okay, don't forget you need a constant though when you're doing integration. The top one, it's fairly straightforward. You will have done this lots of times. So when you integrate, you add 1 to the power and you divide by your new power, and don't forget your constant. The third one here, hopefully you've come across this before. When you integrate 1 over x, you're going to get ln x. Okay, it needs to be a modulus there because you can't do ln of a negative number. Okay, so you must have a modulus after the ln. So just be careful with that one though. Whenever you have 1 over x, you need a ln. But if you were integrating, for example, 1 over x squared, you wouldn't need logarithms for that. You would just do that the same way you normally do the year 1 integration. You'd make it like this, and then you would add 1 to the power and divide by your new power. So you would get that. Okay, so you only need to use a ln if the power of x is 1 on the denominator. For the integral of sine x, I would just think what would differentiate to give sine x. So if you differentiate cos x, that would give you minus sine x. So if you differentiate minus cos x, that will give you plus sine x, which is what you want. In a similar way, if you want to integrate cos x, think what would differentiate to give me cos x. If you differentiate sine x, you get cos x, and so that's it. Now for the others, the others I've listed down here, these are all given in the formula book. That's why they're highlighted. The integral of sec squared is tan x. Hopefully you knew that when you differentiate tan x, you get sec squared. But that could be proved. If you didn't know that, you could always prove that the integral of sec squared is tan x by proving that when you differentiate tan x, you get sec squared. And the way to do that, you probably did this when you were doing the differentiation chapter, but that's the same as differentiating sine x over cos x. And then if you use the quotient rule now, you should find that simplifies to give you sec squared x. I've left out a lot of steps there. I'm sure you'll be able to do that yourself if you remember how to do the quotient rule. So when you integrate sec squared, you get tan x. In a similar way, excuse me, you would be able to prove all the others. This would be minus cosec x. This would be minus cot x. And this would be sec x plus c. So you don't need to learn these ones as they're all in the formula book, although it might be handy if you do learn them off by heart. If you look in the formula book, you'll be able to see, if you go straight to the integration section, you'll be able to see this one here. So that's fairly obvious where that one is. You might, if you look at the rest of the integration section in the formula book, you might be wondering where these three are. Well, those three are actually in the differentiation section, because if we look at, let's pick this one for example, the integral of cosec squared is minus cot x. So if we differentiate cot x, we get minus cosec squared. So if we want to integrate this, we're going to get that. Okay, and then if we look at this one here, if we want to integrate this, we're going to get this. And this one here comes from that one at the top there. Okay, so don't forget, even though we're doing integration, some of these are found in the differentiation section of the formula book. You just need to go the other way, and don't forget to put a plus C. You'll notice that there's a few more integrals down here in the formula book. I'm not really paying much attention to those because you don't need them for the exercise we're going to do, which is exercise 11a and exercise 11b, so I've not really mentioned those. But these ones, all of these here, you're going to need for exercise 11a and 11b. The top ones that aren't highlighted, you're just going to need to learn off by heart. Let's just do one example from exercise 11a. Question 2.3 I think is a good one because it kind of covers everything. Well, not everything, but there's no exponentials in there. But it's a very good practice question. So 2c in exercise 11a, you might want to try it yourself first, and this is how I would do it. So I would simplify I'll break up the two fractions, write them as separate fractions. Now we haven't integrated anything, so we still need the integral sign on the left and we still need the dx on the right. I would then think to myself, well, if I can get any of these, or these obviously, then they'll be easy to integrate. So 1 over sine squared is cosec squared, which is good news because I know how to integrate that from here. Cos x over sine squared, now that's not obvious, but I would try splitting that up into cos x over sine x times by 1 over sine x. The reason for that is I think that is going to give us a cosec cot, which is good news because we know how to integrate cosec cot. So we'll do that in a minute. 1 over x squared is obviously x to the minus 2, and then x over x squared is the same as 1 over x. Still haven't integrated, so we still need the integral sign and the dx. So we've got cosec squared here, which is fine. We know how to integrate that. This we can change, as I mentioned a minute ago. This is cot, and this is cosec. And we're going to be able to integrate that in a minute. I'll just leave this as it is and leave this as it is. All right, now we can integrate everything because we know how to. When we integrate cosec squared, we're going to get minus cot x from here. When we integrate cot x cosec x, we're going to get minus cosec. So I didn't need that plus. I'll write it as minus cosec here. Minus cosec x. And then when you integrate x to the minus 2, we're going to add 1 to the power, divide by a new power. So we could just make that a minus x here. So I'll just make that minus x to the minus 1. And then integrating 1 over x, we're going to use this. So we're going to get ln x. And don't forget to put a plus c down at the end. I don't think you're going to be able to simplify that much. I think I would be tempted to just write x to the minus 1 as 1 over x, but I don't think you would lose any marks if you left it as x to the minus 1. So I think that's the right answer for 2C. Make sure you try quite a few of those, because later on in this chapter you're going to be doing questions like this a lot, where it's just kind of assumed that you know how to use all of these things really well. All right, so make sure you're really good and get plenty of practice for exercise 11A, everybody.